Hi guys, welcome back. Sorry, I am not there again. I somehow managed, after getting over my cold before Christmas, managed to get COVID now. So this is the way it's going to be till sometime next week, it sounds like. So we're going to start the new chapter. I know this is kind of weird to be starting it over a video, but we're going to do our best. Honestly, it's probably one of the easier chapters anyway. So it's probably okay that it's going to be a little weird. So we're going to get started right away. So you have your chapter 5 packet in front of you. And we're going to get started with the chapter called Weathering, Erosion, and Deposition. These are probably words you've already heard, especially weathering and erosion. Up until this point, you've used those words kind of together, weathering and erosion. And up until now, you've probably thought they have similar meanings, or they are even the same thing. One thing we're going to learn this year is that these are 3 very different processes. And for 10th grade Regents Earth Science, you need to know the difference between the 3, weathering, erosion, and deposition. Sorry. So the next 3 slides are actually not going to take any notes yet. We're just going to make sure you know the difference between weathering, erosion, and deposition just a little bit before we get into details about weathering today. So we're going to start with weathering. If you remember when they would talk, we actually talked a little bit about weathering last, when we talked about rocks, when we were talking about making sediments. Weathering, not going to move. Weathering is the breakdown of rocks into smaller particles. And again, you don't need to write this yet. We're going to write it all in a second. So weathering is the breaking down of rocks into smaller particles. There's actually 2 types called chemical and physical. So weathering is the breaking down of rocks. Erosion, so again, you've usually heard weathering and erosion all at the same time. Well, while weathering is the breaking down of rocks, erosion is the movement of those weathered materials from one place to another. And what can move them are wind, running water, waves, gravity, and glaciers. And finally, deposition is when those sediments which were broken by weathering, moved by erosion. Deposition is when they get dropped off. So when the wind stops blowing, or when the water stops flowing, or when the glacier melts, the sediments get dropped off. So again, you will need to know the difference between weathering, erosion, and deposition off the top of your head. This is something that you do need to memorize this year. Up until now, we haven't really memorized too much stuff, but today, or this chapter, there's actually a little bit more memorizing than any of the other chapters. All right, so now to the notes. We're going to start right off on the top of chapter 5, which says weathering. So here we're going to, it's the same slide as before. You can go ahead and add these 2 bullets. Weathering is the breaking down of rocks into smaller particles. And like I said earlier, there are 2 types of weathering, and those are physical and chemical. So we are going to spend the rest of today learning the difference between physical weathering and chemical weathering. And here's actually an example of one. Can you take a guess of whether this is physical or chemical? This is called frost wedging. And here's another example. This one is called oxidation. You guys know it as rust. Can you guess which one's physical and which one's chemical? Well, if you guessed this one is physical, you're correct. And this one is chemical. So let's get into the details. What is physical weathering? So these 3 bullets are going to go right next to those little broken up rocks under physical weathering on page 1 of your chapter 5 packet. So physical weathering does not change the composition of the rocks. If you don't remember what composition is the makeup. So what that rock is made out of, what are the ingredients of that rock. So physical weathering does not change what they're made out of. This happens more in cold, moist climates like ours here in the Buffalo area. And like I said, these rocks are exactly the same. They're just smaller, which actually creates more surface area. So go ahead and get those 3 bullets onto page 1. So we do need to make sure you understand what I mean by creates more surface area. So surface area is exactly what it sounds like. It's the area on the surface of the rocks. Do I not have it here? I'm sorry. Oh, no, I don't have it here. You have that picture right there next to where you wrote. You can see it starts off as a one singular rock. And the surface of that rock is anything on the outside, basically anything that the air is touching. That's the surface area of the rock. When physical weathering breaks the rock into smaller pieces, now you can see that what used to be on the inside is exposed to the air, and now there's more surface area. I like to compare this to if you were to take a Tootsie Pop or a Blow Pop and just leave it in your mouth all class period, versus if you put a Blow Pop or a Tootsie Pop in your mouth and you crunch it up. Once you crunch up any hard candy, it's going to dissolve a lot faster than when you leave it in a whole piece of candy. All right, so now we're going to move on to the different types of physical weathering. And the first type of physical weathering is what we call frost wedging. And then we're also going to be looking at root pry and what's called exfoliation. Like I said, we're going to start with frost wedging. You can put this right in the box next to the picture and in the box labeled frost wedging. This is the only writing that's going to need to go in that whole box. So frost wedging occurs in climates with freezing and thawing temperatures. And the best example of this is with the potholes we have around here. So you might think that those potholes are caused, a lot of people blame the plows for potholes. Now, plows aren't innocent in a whole pothole creation, but plows are not the root of the problem. Potholes are caused when water gets into a crack. And hopefully you guys know this because we kind of already talked about it earlier this year. If not, you've experienced it in real life. If you freeze water, like if you put a water bottle in the freezer, the water expands. So it actually becomes less dense and it expands. So when water gets into a pre-existing crack, which could be caused by multiple different things, but when water gets into a crack and then that water freezes, it makes the crack bigger. And then the next day, when it gets warm enough that the ice thaws, now we're going to put more water into that same crack. And then again, it's going to freeze and make the crack even bigger. And then until you know it, you have a pothole practically big enough to eat your car. If you haven't seen any of these, I'm pretty sure I see them every day on my drive to work on Genesee Road. If not, I'm sure you know what I'm talking about. So frost wedging, you need that freezing and thawing temperature. So you need to go back and forth on a regular basis, again, like we do here. Believe it or not, there's more frost wedging here in the Buffalo area than there is in, let's say, Alaska. Why wouldn't they have as much frost wedging in Alaska? What's different between them and us for their winters? Hopefully what you thought about is that Alaska, once it freezes, it stays pretty darn cold in Alaska all winter long. I'm sure there are some days when it freezes and thaws, but in Alaska, it stays cold all winter long practically. And once the water gets in the crack, it just makes it bigger once. Around here, it's practically every day in the winter where it gets cold enough to freeze at night, thaws in the morning, cold enough again at night, thaws again the next day. So it's that freezing and thawing that happens over and over that creates a lot of frost wedging. This is also referred to as ice wedging sometimes too. So those could be interchanged. The next one is, so here's an example of a pothole. And like I said, pothole big enough to eat a car. So the next one is root action. So just like the name implies, it's when roots do something. So in this case, roots are going to actually, teeny tiny baby roots will grow into and under rocks, and these roots will pry apart that rock. We see this a lot in older towns and villages, like where I'm from here in Eden. We have some older sidewalks and big trees growing next to them. And you'll see, oops, hang on, I'll wait till you guys are done writing. So again, the roots pry apart the rock. So it doesn't just happen in sidewalks, as you can see in this example. We have a tree, which when this tree started to grow, it had teeny tiny baby roots, which could make its way through these individual cracks that are already there in the rocks. But the problem with baby roots is they don't stay cute and little for very long, and they'll grow to be big monster roots that just keep pushing and pushing and pushing those rocks apart. And eventually those rocks are just going to break. This is kind of what I was talking about with sidewalks. We have, I've never seen one quite this bad, but you guys can probably picture this if you've ever ridden your bike down somewhere in Arcade, I'm sure, or Delavan, and you're next to a tree on a sidewalk and you're going as fast as you can and you go over a little bump and you're like, I just flew 20 feet in the air and I'm pretty cool. You know who I'm talking to. I can picture some of you doing this, well, this summer. But anyway, so what you can see here is we got our tree. Now, I have no idea why anyone in their right mind would ever plant a tree this close to a house. I'm assuming this is a house and a sidewalk here, because this was just asking for bad news. But again, the baby roots grew under this sidewalk and there was no problem whatsoever, but those babies didn't stay babies for very long and they grew into these big giant roots that just broke apart the sidewalk. But what I want to point out is it's not just happening here, I'm sure, on the sidewalk. Imagine what's happening to the foundation of this building, the exact same thing. This also happens to pipes. The water main breaks all the time. We had in our backyard a pipe that broke because it was just filled with roots. And again, the roots were fine when they were babies, but they grew into big giant roots that just broke apart anything that was around them. The next one is abrasion. Now, abrasion, you might recognize the word, sounds like abrasive. An abrasive, sandpaper is abrasive. So things that can scratch are abrasive. So abrasion is actually the bumping and rubbing of rocks as they collide. You can picture this in a stream. Streams don't carry rocks, they don't float the rocks. The rocks usually tumble along the bottom of the stream. And every time they bump into something else, a little piece might break off of them. And by little, I mean just a little piece of sand might break off every time it hits something. But if that happens over and over and over again, you're going to end up with rocks that are much smaller, smoother, and more round. again, go ahead and get that into your notes in the abrasion box. So I apologize if I'm going too fast or too slow. If I'm going too fast, just go ahead and pause for a second while everybody catches up. If I'm going too slow, well, I'm sorry, just deal with it. Hopefully if you have any suggestions for me, you can go ahead and message me on Teams on how to make this better for the next week or so. So again, abrasion, you do need to know, again, that the rocks become smaller, smoother, and more round. Now, the last one is exfoliation. Oh, I'm sorry, I have a picture here. So this is actually a beach where my parents took me when I was a kid. It's in Massachusetts, and this beach is, as you can see, there's no sand. This beach is made out of nothing but pebbles. I don't know, do I have a picture? So you can see how big, so it's the same beach here. It's called Pebble Beach in Rockport, Massachusetts. You can see that some of these are big, some of them are small. Again, here's a close-up view. One thing that you should see or notice about all these rocks is most of them are quite smooth, and there are some that are perfectly round. Now, if I was in class right now, I have one in school that is a perfectly round, looks like a little golf ball. And how this happens is every day when these waves push against this beach, these rocks get pushed up and they roll up the beach. And then when the waves go down, they roll down the beach. So every day, all day long, these rocks are rolling up and rolling down the beach over and over and over again. And it's making them these perfectly smooth, round rocks. It's actually really cool. The next one is exfoliation. Now, exfoliation, some of you might know that exfoliation, if you exfoliate your face or if you use an exfoliating body wash, what that body wash or that face cream is doing is it's actually removing the top layer of skin, typically dead, flaky skin. And here, exfoliation of rocks is the same idea. It's when the surface of the rock peels off. And I have a picture of that for you as well. So here you can see we have like the top layer of these rocks are peeling and sliding down this hill. Sorry. And you have underneath a stronger, different kind of rock. So these rocks are just wearing away in layers. All right. So again, those were the 4 different types of physical weathering. You do need to know what physical weathering is. You need to know the 4 different kinds, and you need to be able to explain the 4 different kinds of physical weathering. All right, so we're going to wrap this up today with chemical weathering. So if you guys could go over to page 2 right now, just flip on over. So physical weathering, again, remember, was the breaking down of rocks into smaller pieces, but without changing the chemical composition. So you can imagine what chemical composition or chemical weathering is. Now we're going to be breaking the rocks into smaller pieces by changing their chemical composition. This happens more in warm, moist climates, and it occurs on just the surface of the material. So go ahead and write those 3 bullets at the top of page 2, right underneath where it says chemical weathering. Oh, I knew that was going to happen. So you might see some similarities in these two definitions. Again, they both break down rocks into smaller pieces. But if you remember, physical weathering created more surface area. And now chemical weathering happens on the surface of the rock. So as we have more physical weathering, that makes more room for chemical weathering to happen. So physical and chemical weathering, they're pretty close friends. They work hand in hand together. All right, so just like physical weathering, we only have 3 types of chemical weathering. And the first one is oxidation. Hopefully when you hear the word oxidation, you hear oxygen in there. So oxidation is when iron atoms combine with oxygen to form rust. So oxidation is just a fancy name for rust. So I'm actually going to put the word rust right in that box in big bold letters so that I don't forget that oxidation just means rust. Now you're familiar with rust on metal. So you might have like a rusty shovel, or your car might have some rust. What you'll notice with like a rusty car, rust is completely different than the metal it used to be. It has a different texture, a different color. It's not as strong. If you could smell it, it would smell different. If you could taste it, it would taste different. They are different actual compounds. So they've got the metal that changes into rust. They're completely different. So that is an example of how it changes the composition of whatever it's happening on. So we're more familiar with rust happening on metal. Well, if you remember from when we did rocks and minerals, iron can be found in different rocks. So here we have an example of a rock that contains iron in it. So this rock will actually rust just like if you left a hammer outside and it rusted. Now this looks pretty gross, but all this is if water now runs over those rusty rocks, you'll get rusty water. This can happen in a house as well. So if you have a rusty pipe and you put water through it, your water might come out rusty color for a minute. And honestly, if nothing bad's going to happen to you if you drink that rusty water, but it would potentially stain clothes. Same with rusty water, you can have rusty dirt. So you take those rocks that had rust in them and then they get broken down and now you have rusty dirt. And this, any of you have ever watched Walking Dead, especially the early seasons when they were still in Georgia, if you can picture the color of all of their clothing, their whites turned almost like a peachy color. The dirt on their face was almost a peachy color. And that's because they were in Georgia. I believe they were in Atlanta. Don't quote me on that. But they were in Georgia, and Georgia has a bunch of rusty or iron in their rocks. So then those rocks rust and then they break down, and the dirt in Georgia is this reddish color. Side note, I don't know if you guys remember, but I had 2 llamas. Now I have 1. And when we used to go to llama shows all over the country, when we went to this one show, I believe it was in Virginia, but there was llamas from Georgia. They didn't bring any white llamas with them. They actually brought pink llamas because any white llama that rolled around in rusty dirt became pink, and it was pretty cool. All right, so I think we're running out of time, so let's keep going. Oh, and there's an example of classical rust. Oh, one more. So in case you didn't know about this, the Statue of Liberty should be the color of a penny. The Statue of Liberty is made out of copper. The Statue of Liberty is standing, if you guys can picture where she is, she's surrounded by an ocean, and that ocean is salty. So when you put salt water onto copper, you actually get this greenish color, and this is called a patina. So it's not really rust, but it's basically the same idea as when the metal changes completely into a different color or different compound. All right, carbonation. This is when carbonic acid in rain causes the minerals to dissolve. This is acid rain. So you can see how I have up there acid rain. Go ahead and put that first. Acid rain will cause major damage to some rocks, such as marble. And oh, hopefully this is ringing some bells from chapter 3. So see how Earth Science is bringing chapter 3 back into chapter 5. So you hopefully remember on the back page of your reference table that there are 2 minerals that will dissolve with acid, calcite and dolomite. So any rock that has calcite in it will actually bubble with acid. So if you put acid rain onto these marble, which is made out of limestone, which is made out of calcite, you can actually see that they will dissolve the gravestones. And this one's pretty extreme, but I'm sure you've seen similar ones in older cemeteries where you can barely read what's there. And what has happened is the acid has eaten away at the marble. All right, here's another statue where, again, this was a statue that was out in the acid rain and it got eaten away. And finally, the last one is hydration. So hydration, just like the word implies, hydrate, it involves water. So this is when water weakens the rock. And then the rock will crumble. So you take any of those sedimentary rocks, if you remember, they're basically held together with clay, and you add water to them and they will start to just basically break down. All right, so hopefully you've gotten the chemical and physical weathering. Like I said, you do need to know the difference between the 2 different types of weathering, and you are responsible for knowing the 3 types of chemical and the 4 types of physical weathering. And you do need to be able to describe the differences and compare and contrast them. And we'll continue on with weathering a little bit tomorrow. You have no homework for tonight. And I will talk to you again on Zoom tomorrow.